Hi everyone, so today we're going to be taking a look at something interesting or maybe not interesting depending on how the test actually goes. So we're going to be putting this model to the test and it's called Marco-o1 as you can see here. And they said it's an open large reasoning model for real world solution by Alibaba International Digital Commerce Group. Now Alibaba is actually backing a whole lot of models and I think one of them is Quen. I think that's one of the models they are actually backing, and that model is actually really good at tool calling and function calling. And even Quen 2.5 coder is really good at coding. So they've been really doing awesome work in the open source community. But this one is an open, large reasoning model. And whenever we actually hear reasoning model, we have to actually take it with a grain of salt because the next thing we're going to hear is COT. And sure, that's what we heard here. And it said fine tuning with COT data. We developed Marco-o1 COT, that's your data set, by performing full parameter fine-tuning on the base model. The base model is Qwen2. On the base model, using open source COT data sets combined with our self-improved synthetic data. So basically what we're actually getting is a model that was trained on reasoning using chain of thought. And they also did something else called Monte Carlo Tree Search. So as you can see over here, it says we integrate LLMs with MCTS. They said it's using the model's output confidence to guide the search and expand the solution space. And then something else they actually took a look at was the Marco-o1 MCTS mini step using 32 and also 64 tokens instead of just one token at a time and all that. They also said in terms of translation task, it was actually good, especially for nuance, like especially for multilingual translation with slangs and all that. So we're going to be taking a look at this on Olama since it's actually out on Olama. I don't know if it's out on LM Studio, but today we're going to be taking a look at this. But first of all, if we go over to the paper, I have downloaded the paper and I've opened it up on my Adobe Acrobat. And okay, now if we go over to the top, as you can see over here, it says Marco-o1 is powered by Chain of Thought, like we actually read in their model spec, fine-tuning, Monte Carlo Tree Search, like we actually read, reflection mechanisms. Now we're going to talk about this shortly, and innovative reasoning strategies optimized for complex real-world problem-solving tasks. Now let's scroll down. It says Marco-o1 leverages advanced technique like COT fine-tuning. I do not know why they actually proudly say this, but anyways, let's continue. MCTS and reasoning action strategies to enhance its reasoning power. Okay, now this was in the model spec, so we don't need to go over this. Okay, something else we can actually take a look at is this mini step as actions. We used mini steps of 32 or 64 tokens as actions. This finer granularity expands the solution space and improves the model's ability to navigate complex reasoning tasks by considering more nuanced steps in the search process. Now, another part I actually highlighted on this paper is this. We introduced a reflection mechanism by adding the phrase, wait, maybe I made some mistakes. I need to rethink from scratch. Now, this part was really annoying, honestly. And it's under reflection after thinking. And they said at the end of the thought, like at the end of each thought process, which basically is like hard coding a prompt at the agent level and just feeding it to the LLM to always check its work just to self-reflect. So to me, this was actually really annoying because, like I said, it's like hard coding stuff in. And even when I hear something like COT, to me, chain of thought, like what they actually did was moving it from the agent level or from the normal software level back to the LLM level, which was, it's not revolutionary at all. It's not, because it's basically like fine tuning, it's still like training the models. It's not like the model is actually learning or truly reasoning. They are just knowledge base that are actually frozen in time. Like sometimes we actually need simple answer, especially if that knowledge base is up to date. You should just give a straightforward answer. But if it actually needs to think through something, it should do that. But it should also know the difference. It should also know when to actually think through stuff and when to give just a simple answer. So if you're an AI researcher and you've gotten to this part of my video, you've gotten to this part of my rant, basically, thank you. But something I would actually like you to consider is creating an AI system that can actually learn, that has dynamic weights where it can adjust itself by itself, like something that can actually learn, not just obsessing over COT and all that. That has been done on the agent level already. Doing it on the LLM level is not that revolutionary, even though it's is great in some ways because of inference time scaling and all that, and dense time compute. That's all nice and good. But I think the main thing that would actually be revolutionary is creating an AI model that can actually learn, where the weights are actually, or the parameters are actually dynamic. I think that would be really, really cool, because that will actually give rise to models that can do things at the human level, because it can actually learn faster than a human, but it can also retain knowledge more than a human. It can access those knowledge in record speed, depending on the server it's actually sitting on, which is really, really amazing. Especially how long it actually takes people to learn stuff, and for their brains to actually develop, and for them to get into the workforce and all that. It will eliminate a lot of, like, it will replace a whole lot of people, and it will also save the training time. Like, it will save you a lot of training time, which will save a lot of cost instead of scaling it up to the moon. I think that's the best way to actually approach this problem. So you would actually have truly capable models that can learn, and they truly understand what they're actually learning. Then they can actually reason through tasks, especially tasks similar to what they have actually solved earlier. Now, that to me is actually true reasoning. So let's go on with the video. Sorry about the rant. Now let's go back to their Olama page. And to download this model, you're going to have to copy this and paste it in your terminal. If you want to pull this model and maybe use it later, and you don't want to run it yet, but you want to download it for now, you can change this run to pull. But if you want to run this now, the moment it's done downloading, if you've not downloaded it yet, then copy this and paste in your terminal. It's going to check if the model is already downloaded. If it is downloaded, it will run it. If it is not downloaded, it will download it before it runs it. So let's go over to our terminal. Now let's run this code, and we have loaded up Marco-o1. Now we're going to ask it a question, and the first one, like I said earlier, is this. And let's see if it can actually get this really simple one. This is what they actually use in their paper as their key example. So, but they actually phrased it a different way. But let's see. Okay, it's having a thought, as you can see in this tag here, thought. Okay, it actually got it, because its output is there are 3 R's in strawberry. Now we're going to close this up. We're going to kill Olama, and we're going to load up this model again, and we're going to ask it this same question so it doesn't load it up from memory. Let's do that now. Okay, now we're going to run this. That's nice. Now let's paste this question again, and let's see if it actually gets it. Okay, it still got that question right. Now let's ask it a different question. So this is the next question we're going to be asking it. How many words are in your response to this particular message? And if it actually tries to get the previous message, because it actually has the chat history for this particular session, and if it actually tries to check for the previous message, we're going to close up this terminal and restart Ulama, so it will just start afresh, because I need it to get the response to this particular message I'm sending it right now. So let's see what it will do. See, it's actually evaluating the previous message, which is not what we want, and it's going to spend a very long time doing this. So let's just exit this. Let's terminate this. And let's open up the terminal again. Okay, and let's ask it the same question again. Okay, that's good. So it actually got this wrong. It just output 12. Since this is the output, that's what we're supposed to take seriously, not its start. And even its start is really lengthy. It's way more than 12 words. So we're going to give this a fail. And upon all this contemplation, it still failed this simple question. But anyways, let's ask it a different question. So let's close this and let's run it again. And okay, this is the next question we're going to be asking it. A small ball is put into a normal cup, and the cup is placed upside down on a table. Someone then takes the cup and puts it inside the microwave. Where is the ball now? And I'm going to clear out this, explain your reasoning step by step, since this is a chain of thought fine-tuned model. So it should do that by default, like it did when answering our previous questions. So let's run this and see. It said the ball is now inside the inverted cup. Okay, it said after placing the inverted cup containing the ball. No one said it's containing the ball. It's just made this up on its own. After placing the inverted cup containing the ball into the microwave without any changes to its position or movement, the ball remains inside the inverted cup. Oh my god. It actually failed this in flying colors. It failed this. Wow, this was a major screw up, because if you scroll up here, you can see that it actually says when you place an object inside the cup and turn it upside down, gravity causes any liquid or objects to fall towards the bottom of the cup. What are you saying? Just look at what it's saying. If there is no liquid in the cup, the ball should remain suspended within the inverted cup without touch. Oh my god, where's it getting its physics from? The moment you actually flip an inverted cup, whatever is inside will drop. If it doesn't have a flat bottom, if it doesn't have a bottom, and it's a cup, so one side is open, then it went ahead to the microwave. It didn't even evaluate if the cylinder or whatever it's actually using as its frame of reference has one side cut open like a cup. Anyways, this was really bad and it's a major failure. As you can see, the outputs section, it said the ball is now inside the inverted cup on the table inside the microwave, which is total gibberish. Anyways, let's go as usual. Let's restart. Let's start fresh and let's go over to the next question. So this is the next question we're going to be asking it. John has 10 apples. He gives away 4 and then receives 5 more. How many apples does he have? Really simple and straightforward. Let's see if he gets it. And as you can see right here, this is actually a pass. It said John has 11 apples. And if we go to the top under the third section, it says, all right, let's figure out how many apples John has after these transactions. Initially, John has 10 apples. Then he gives away 4 apples. So if I subtract the 4 apples he gave away from his initial 10, that leaves him with 6 apples. And that's correct. Now, John receives 5 more apples. To find out how many apples he has now, I need to add these 5 apples to the 6 apples he had after giving some away. So 6 plus 5 equals 11 apples. That's good. Now, if you look over here, you're going to see the prompt that actually allows the model to self-reflect while doing chain of thought. So it's like, wait, let me double check that. It's basically like what they actually wrote in their paper. If we go over to their paper, you're going to see what I'm talking about. It says here, we introduce a reflection mechanism by adding the phrase, wait, maybe I made some mistake. I need to rethink from scratch. So it's similar to that. It's just a synonym of that particular phrase, of this particular phrase. If we go back, we're going to see that it said, wait, let me double check that. So it started again, starting with 10 apples, subtracting 4 gives 6, and adding 5 brings it back to 11. That seems correct. Alternatively, I could think of it as 10 minus 4 is 6, and 6 plus 5 is indeed 11. Is there another way to look at this? which is just complete waste of time, but here we go. Maybe by considering the net change in apples, he gave away 4 and received 5. So the net gain is 1 apple. Starting with 11, adding 1 gives him 11 apples. That matches my previous calculations. Just to be thorough, let's visualize it. Imagine John has 10 apples. He gives away 4, leaving him with 6. When he receives 5 more, bringing his total to 11. Yes, that makes sense. So after giving away 4 apples and receiving 5 more, John ends up with 11 apples. Really nice train of thought. Really nice. He didn't actually lose any train of thought. So that was really cool. Now let's exit this and start again. So we've actually closed the terminal, and now let's move over to the next question. So let's run this. So this is the last word problem we're going to be giving this model. The next one is going to be a coding problem, but for now, let's read this. Which is a faster way to get to work? Option 1, take a 1,000-minute bus, then a half-hour train, and finally a 10-minute bike ride. Option 2, take an 800-minute bus, then an hour train, and finally a 30-minute bike ride. So let's see what it actually does. Yeah, and it actually got this correct. That's option 2 is faster. Yeah, it's a very simple question and it would have been really disappointing if it actually failed this very simple one. And as you can see over here, it's calculated it in minutes and then broke it down. But wait, maybe there's more to consider. It just keeps doing that thing. This same thing we actually talked about in the paper. It's kept doing the self-reflection by self-prompting, and it said, but wait, maybe there's more to consider, and I think it will do it here again. However, I should consider if there are any hidden factors. As you can see, it does self-reflect on its own. Which means initially I was actually being hard on them when I actually said they just had coded that particular prompt, and this is actually way much better and way more intuitive because it does this self-reflection and it's not the same phrase. It doesn't use the same phrase over and over again. But the way they actually wrote it out on the paper, it seems like that's what it meant to do. But when we're actually trying it out now, that's not what it's actually doing. Now, the output section, it says option 2 is faster, which is absolutely correct. So let's just go over to the last and final question, which is a coding problem. So let's exit this again. Now let's run it. And this is a simple coding question we're going to give it. Write me a snake game in Python. It's really simple. We want to see if it's going to use the chain of thought and also the self-reflection to give a very, very good output to produce a game that actually works, that we won't actually run into any problem like import problem. So let's see if it will automatically fix itself while in the thought process. Let's send it. Okay, it's still planning. Want to know if it's going to write code. Okay, it's writing the code. It's doing it in the output section and it's done. Let's copy this. And I'm going to go over to a project I already have set up that has a virtual environment, so I do not need to set Pygame up and all that and set up a new virtual environment, so I can just easily run this to see if it will work. Now let's open up PyCharm. Okay, we're going to run the code and we can't find any errors here. We can't see any errors, so everything looks good. So let's run the code and see. And as you can see, I'm moving the arrow keys and it's not working. It's just game over. Let's go back to our terminal. So for this final question, it was definitely a fail since the game was unplayable, and if you can't play it, it's definitely not a game. So, but I was actually hoping that while it's actually going through its thought process, it would output some chunks of code and go over it till it actually gets it right. That's what I was actually hoping on. Maybe whenever they actually decide to use the Qwen 2.5 coder for the base model, maybe it will actually do better at coding. I do not know, but it didn't actually refine the code like I was actually hoping for. It just wrote this whole essay in the thoughts section and then went on to write the code in the output section, which at the end of the day, it will still be a flop because it didn't actually go over the code. That was the main thing. If it could actually perform self-reflection while actually writing code, that was the main key. But it actually failed at that, which means it just outputted this whole thing from memory, and as usual, it actually flopped. But there are a few models that have been able to answer this question without needing chain of thought or self-reflection prompts, and they would actually give you a much functional snake game. So maybe it's just terrible at coding. And so after the problems we actually passed to the model, I noticed the self-reflection doesn't help the model self-correct. Like when we actually gave it the problem number 3, which was the cup, the small ball, and the microwave problem, it initially made a mistake. It made an error initially, but upon self-reflection, it still did not correct that mistake. So it actually begs the question, and you have to actually wonder what is the point of the self-reflection if the moment it actually makes an initial error, it doesn't self-correct, even after going through the self-reflection, even after wasting so much time with the chain of thought. So I think it's a complete waste of time for a user. Let's say you actually integrate this model into a product. It's a waste of time for the user because the moment it actually makes an initial mistake, like every model do a lot of times, it will never fix the problem, but instead what the user will get is an extra time, like doing this chain of thought and acting like it's actually reasoning, but it's basically not. And all the user will get is just added latency, added waste of time. So that's what I actually see. And because of these and many other personal reasons, I don't see the point for the creation of this model. Basically, I honestly don't. But let's see if a better variant would actually emerge in the future, or it would actually pop up from this model, maybe a different variant, or let's say the next iteration, the next version. Let's see if it will be better than this one. That's something to actually watch out for. And another thing to actually watch out for is this. This is another model, but this is actually a VLM, but it was also trained on chain of thought. I think they have their own data set, and It's officially called Lava-o1. And you can actually check out the project. You can check out their Hugging Face page and all that. But you can also go and check out their paper. They have a paper. If you go over here, as you can see, you can click on view paper, but I already have it opened up. So something that's actually similar in both models but quite different is this, the reasoning stages. For the Lava-o1, it actually has 4 different reasoning stages: the summary stage, the caption stage, the reasoning stage, and also the conclusion stage. This caption stage, since it's a VLM, that's actually really important. But the Marco-o1 only has the thought and the output. That's all it has. Those are the 2 tags it actually has. So another thing that actually differentiates the both of them is the Lava-o1 actually uses inference time stage level beam search method, while the Marco-o1 uses the Monte Carlo Tree Search. I think they talked about it a whole lot here. So that's something that actually differentiates the both of them. You can actually check out the paper and just read it for yourself and see what you think. But I'm actually waiting for it to actually drop on Olama or LM Studios so I can play around with it and put it to the test, just like we did today with Marco-o1. And maybe we'll be doing a comparison of the both of them, but let's wait and see. For now, if you do have the GPU, you can actually check it out here. You can go to the Hugging Face page and all the tensors are here, so you can actually play around with it. And I think they also have a code example, I think so. So you have to go to their GitHub page to actually check out their code example. But for me, I cannot actually say these models that are trained on COT, like the O1 model and all that, that they actually reason, because to me they do not actually reason. Because if you put them to the test, you'll notice that they don't actually reason. So make sure you do like, subscribe, and hit that bell icon if you want to be notified when a new video comes out on this channel. It really helps a lot, especially as we're on our way to our first milestone, which is to get to 1,000 subscribers. It really helps a lot. So thank you for watching. Have a nice one.